In section 5.4, we're looking at special products. Our objectives are to multiply two binomials using the FOIL method, to square a binomial, multiply the sum and difference of two terms, and use special products to multiply binomials. Let's multiply these binomials using the FOIL process. Let's begin with the first, the quantity x plus 7 times the quantity x minus 12. When we multiply x times x, that's the f. So that's going to be x times x is x squared. Our outer is when we multiply x times this negative 12 to get minus 12x. That's our outer. And then the inner is to multiply this plus 7 times x plus 7x. And then the last is the plus 7 times negative 12, which is negative 84. And then we can combine like terms. Notice that the minus 12x and the plus 7x are like terms. So when we combine those, we get our final answer of x squared minus 5x minus 84. X squared minus 5x minus 84 is our answer. Let's look at the second example using the FOIL process. First, outer, inner, last. We begin multiplying 3x times 2x to get 6x squared. That's our first. Our outer is 3x times a positive 5, so that's going to be 3 times 5 is 15x. The inner is negative 1 times 2x, negative 2x. And then the last is negative 1 times positive 5, or negative 5. We combine those middle two terms, or like terms, to get 6x squared plus 13x minus 5. Let's continue with part C. We have the quantity a minus 2b times the quantity a plus 12b. By using the first, outer, inner, last, we multiply a times a to get a squared, and then the outer is a times 12b. That's going to be plus 12ab. The inner is the negative 2b times a minus 2ab. And then the last is negative 2b times 12b, which is negative 24b squared. We combine those middle two terms, a squared plus 12ab minus 2ab. Since the middle two terms are like terms, we can simplify to get plus 10ab minus 24b squared. So our final answer, a squared plus 10ab minus 24b squared. In our next example, we're multiplying the quantity x plus 3 over 7 times the quantity x minus 1 over 6. We can still use the FOIL process here. We can do that whenever we're multiplying a binomial times a binomial. So when we multiply the first times the first, x times x is x squared. The outer is x times a negative 1/6, so we can write that as a minus 1/6x. The inner is plus 3 over 7 times x plus 3/7 x. And then the last is plus 3/7 times a negative 1/6, so it's going to be a negative 3 over 42, which we'll be able to simplify. Let's simplify our answer. So we get x squared. Since the middle two terms are like terms, we can combine those, but they have fraction coefficients. So recall, I'll do the addition over here, a negative 1/6x plus a 3/7 x. You need to get a common denominator, or you can use the fraction button on your scientific calculator. To get a common denominator, you would have to multiply the top and the bottom of the first fraction by 7, and the top and the bottom of the second fraction by 6. So the fraction becomes negative 7 over 42 plus 3 times 6 is 18 over 42. So you can add fractions if they have a common denominator, and negative 7 over 42 plus 18 over 42 is 11 over 42. So when we're adding these terms together, negative 1/6x plus 3/7 x that combines to plus 11 over 42x. And then the 3 over 42 you can simplify by dividing both the numerator and the denominator by 3, and that fraction reduces to 1 over 14. So our final answer is x squared plus 11 over 42x minus 1 over 14. For these examples, we want to multiply. In each of these cases, we are squaring a binomial. In A, we have the quantity x plus 4 squared. We could write that as x plus 4 times x plus 4, and then use the FOIL process like we did before, where the first, x times x, is x squared. The outer, x times plus 4, is plus 4x. The inner is plus 4 times x, or plus 4x. And the last is plus 4 times plus 4, or plus 16. The middle terms are like terms, so we can combine those to get x squared plus 8x plus 16. Now you could repeat this for all of these when we're squaring a binomial, or you could recognize that this is a special product, and there's a formula that we can use to multiply. So here we have a special product patterns. What we just did was a square of a binomial pattern. And we had a quantity, two variables added together raised to the second power. And that's always going to follow this pattern of the first term squared plus twice the product, and then square the last term. You can do the same thing if it's a minus b, two quantities squared. It's always the first term squared, twice the product, square the last term. So let's look at using a shortcut for part B. We could write it as 3x minus 5 times 3x minus 5 and use the FOIL process. But in the FOIL process, those middle two terms are going to be the same whenever you're squaring a binomial. So we can write this as squaring the first term. 3x times 3x is 9x squared, twice the product. In other words, the outer is minus 3x times a negative 5, or negative 15x, and the inner is also a negative 15x. So it's always going to be double the product of the first and the last term. So that is going to be a minus 15x, and another minus 15x is going to be a minus 30x. And then square the last term. A negative 5 times a negative 5 is a positive 25. So you can double check that with the FOIL method if you like, or you can recognize that this special pattern here, where we're squaring the first term, twice the product, and squaring the last term. Let's do the same thing for part C. We square the first term, 5x squared is 25x squared. Twice the product, if you multiply 5x times negative 3y, that's minus 15xy, but double that. So minus twice of 5x times 3y, and then square the last term. 3y squared, negative 3y times negative 3y is going to be a positive 9y squared. So this will look like a 25x squared minus 2 times 5 times 3, or minus 30xy plus 9y squared. Again, you could write that problem as 5x minus 3y times the quantity 5x minus 3y and use the FOIL method and get the same result. Let's look at example D. We have the quantity 7a to the third minus 4 all raised to the second power. Using this shortcut, we can square the first term. 7a to the third times 7a to the third is 49a to the sixth power, twice the product. 7a to the third times is negative 4, so it's going to be minus 2 times 7a to the third times 4, twice the product, and then square the last term. Negative 4 times negative 4 is 16. So we can write this as 49a to the sixth minus 2 times 7 times 4, which is minus 56a to the third, and plus 16 as our final answer when we're squaring a binomial. In these examples, we want to multiply the sum and difference of two terms. In example A, we have the quantity y minus 3 times the quantity y plus 3. Now you could use the FOIL process here, and you can multiply y times y to get y squared. Y times plus 3 is plus 3y. And then the inner, negative 3 times y is minus 3y. And the last is negative 3 times a positive 3 is a negative 9. Now you'll notice something interesting for these problems is that the middle terms are always going to be opposite. Whenever you're multiplying a sum and difference, or difference, sum of difference, you will end up with a binomial solution that we can write as y squared minus 9, because the plus 3y and the minus 3y, the middle terms are opposite. And this happens whenever we have the special pattern. And the pattern here is what we call a sum and difference pattern. Whenever you have a quantity a minus b times a quantity a plus b, then the difference pattern results in a squared minus b squared. So you square the first term, square the last term, and you subtract. So this is called the sum and difference pattern. Let's look at using that shortcut for example B. So the first, we're going to square 5x and 5x to get 25x squared, and then we're going to multiply the negative 1 and the positive 1 to get minus 1. And if you were to do the outer and the inner terms, those are going to be opposite. So our final answer is 25x squared minus 1, and you can double check that using the FOIL method. Let's look at example C. Again, we recognize that this is a special pattern. It's in the form of a minus b times a plus b. So using the sum and difference pattern, we know that we can write this as squaring the first term. 2x times 2x is 4x squared, and then the negative 3 over 5 times a positive 3 over 5 is negative 9 over 25. The outer and the inner, if you check that, those are going to be opposite terms. So this is our solution when we multiply the sum and difference. In example D, it follows the same pattern. We have 10x minus 7y times the quantity 10x plus 7y. We have it in the form of a minus b and a plus b. So the result is a squared minus b squared. When we multiply 10x times 10x, that is 100x squared. And negative 7y times positive 7y is negative 49y squared. The outer and the inner will cancel out because it follows the sum and difference pattern. Our final answer is 100x squared minus 49y squared. So let's put it all together in the next examples, which is mixed practice, where we can multiply using special products. Here we're squaring a binomial. When we square a binomial, we use that binomial where we square the first term, n times n is n squared, twice the product, 2 times n times 13, and square the last term, 13 times 13, 169. When we simplify this, we get n squared plus 2n times 13 twice the product, which is 26n, plus 13 squared, which is 169. Okay. In part B, we have a minus 4y times a plus 11y. This doesn't follow any one of those special products, so we can use the FOIL method here. A times a is our first, is going to be a squared. The outer, a times 11y, is a plus 11ay. Our inner is negative 4y times a, or minus 4ay. And our last is negative 4y times a positive 11y, which is equal to negative 44y squared. We can combine those middle terms and write our result as a squared, and 11ay minus 4ay is 7ay minus 44y squared. Our final answer, a squared plus 7ay minus 44y squared. Okay, in the example D, we have the quantity 3x plus 5 times the quantity 3x minus 5. This is the sum and difference special product. So when you do this one, you multiply 3x times 3x and get 9x squared, and you multiply the plus 5 and the minus 5 to get negative 25. In this case, the outer and the inner will be opposites, and they will cancel each other out. So our final answer is 9x squared minus 25. Let's multiply e, which is a quantity negative 5a squared plus 10b times a quantity negative 5a squared minus 7b. This doesn't follow any of those special patterns, so we can use the FOIL method to simplify this. We multiply negative 5a squared times negative 5a squared and get a positive 25a to the fourth power. Then our outer is negative 5a squared times negative 7b, which is a positive 35a squared b. The inner is 10b times negative 5a squared, and that's going to be a negative 50a squared b. And then the last term will be 10b times a negative 7b, or negative 70b squared. When we combine like terms, the middle two terms are like terms, so we can write our final answer as 25a to the fourth, 35a squared b minus 50a squared b. Those are like terms. And when you combine, you get negative 15a squared b minus 70b squared. So that's our final answer, 25a to the fourth minus 15a squared b minus 70b squared. For example F, we have the quantity 2x minus 4 sevenths and the quantity 2x plus 4 sevenths. This is that sum and difference product. So there is a shortcut for this where we square the first term, 2x times 2x, which is 4x squared, and square the last term, 4 over 7 times 4 over 7, which is 16 over 49, and this is going to be a minus. If you did the FOIL process here, the outer and the inner would be opposites, so our final answer we can write as 4x squared minus 16 over 49. For example G, we have the quantity 4x plus 13y quantity squared. This is one of those special cases where we're squaring a binomial. You could write it as 4x plus 13y times 4x plus 13y and use the FOIL process. However, since we could recognize that we're squaring a binomial, you could use the fact that you square the first term, 4x times 4x is 8x, and then 8x squared, sorry, and then it's going to be twice the product, 2 times 4x times 13y, and then square the last term, which is 13y times 13y, or 169y squared. Let's simplify the middle term to get 8x squared plus 2 times 4 times 13, that's going to be 364xy plus 169y squared. As our final answer, 8x squared plus 364xy plus 169y squared.